Hello, my name is Taylor Blocker, and this is Lab 5 Magnetic Braking with Faraday's Law. The purpose of this lab is to use fundamental elements of Faraday's Law to collect observational data of a falling magnet through a conductive tube, model the magnet and tube's interactions, and compare the observed and computational data. We will use Faraday's Law, the law for current, Biot-Savart law, and the magnetic field of a bar magnet formulas to complete this lab. The system in this lab is defined as the bar magnet, and the surroundings are everything else. We will see that the time computationally was 12% less than the time in our observed model. Now let's look at our experimental model. To set up the experimental model, I measured the dimensions of my tube of foil along with the bar magnet using my smartphone to find north, and then I also calculated the average time for 5 trials of the bar magnet falling through the conductive tube. Now let's look at a computational model. The first part of the code was to establish our physical constants such as gravity, resistivity, and mu0 over 4 pi, to initialize our graphs of velocity versus time, and to create the tube of aluminum foil using its measured dimensions and setting it up as multiple rings. Next, we created the bar magnet using its mass and its magnetic dipole moment measured from Lab 3. We initialized velocity and time, and then we calculated the magnetic field of the bar magnet. The next part was to create a function that calculated the magnetic flux through the ring from the magnetic field of the bar magnet. The final part of the code was to create a loop to calculate the EMF induced in each ring of the tube as the bar magnet falls through the tube, and to also calculate the magnetic force on the ring and thus the magnetic force on the bar magnet using Newton's law of reciprocity. Our computational model calculated that the bar magnet's time in the tube was 1.026 seconds. This is 12% less than the average time calculated from our experimental model. Now let's talk about these results. What if the resistivity was lowered? The force would counteract gravitational force, and the bar magnet would not be able to fall through the foil, and this would be maximally efficient. What if there were holes or cuts in the tube? If there were holes in the tube, flow of the current would be interrupted by these holes, and this would decrease the magnetic force opposing gravity and thus decrease the amount of time the bar magnet is in the tube. Some possible sources of error for this experiment were the timing in experimental models has some human error, also that the thick cardboard could insulate some of the current, and that the magnetic dipole moment calculated from Lab 3 could have some error in it. Thank you for listening to my Lab 5.